Hello everyone. Today in this video I will be discussing on a VLSI design, how the VLSI design course has been framed up, and what are its objectives of this course and what are its outcome once we learn this course. Myself, Sayyid Zahiruddin, Assistant Professor, Department of VC, Kids Varangal, and at any time you can contact me onto the mobile number given on this PPT, as well as for any queries related to the subject you can mail me on the email address provided over here. This course VLSI design is being framed under for the first autonomous batch under the scheme of URR 814, and this has been under the Department of Electronics and Communication for the final year students. Let's start. The objective of this course is to make the students gain knowledge on the course learning objectives and their outcomes that will be gained after the completion of VLSI design course. So then after this one we will be looking at the contents of the syllabus frame for URR 14 EC 702, which is the code for VLSI design course. So these are the list of the objectives which are being listed out for the VLSI design course. The first objective, each objective is made as an unit for framing the syllabus. The first objective is fabrication process and electric properties of MOS transistors. On the completion of a unit 1, the students will gain knowledge in fabrication process and electrical properties of MOS transistors. Similarly, on completion of unit 2, you will be gaining the concepts of stick diagrams and mask layout for MOS circuits. For the third unit, you would be getting the knowledge in scaling of MOS devices and subsystem design with structured approach. And finally, once it completes 4 unit, this is the objective of 4th unit, basic concepts of Verilog and description of various levels of abstraction, behavior, data flow, gate level and switch level will be discussed in the 4th unit. So on these objectives, the 4 units have been designed. Let's have a look at the syllabus, how the syllabus has been framed. So the first syllabus, and this course is being designed for 3 theory classes and 9 theory classes and 3 tutorials, which will be taken online itself. And the first unit comprises of review of microelectronics and introduction to MOS technology. Under this one, you will be having first you will be learning on IC technology, followed by the MOS transistor, how the MOS transistor is built up, how the characteristics curves are being defined for the MOS transistors. Then you will be learning on what are the different types of processes for fabrication, like photolithographic process, etches, deposition. Then after learning all these processes, we will be moving at how the fabrication of NMOS, CMOS, BiCMOS will be carried out. Then for the conduction of this fabrication, we require a certain marks. So you will be getting a knowledge of production of how EV mass is being produced. We'll be reviewing on to that one. This is the first part of your first unit. After this one, we will be discussing on the basic electrical properties. So the first one would be the drain current versus the source current relationship, IDS versus VDS relationship. Then we'll be discussing on the thermal aspects of the threshold voltage, how the threshold voltage has been impacted on the MOS device. Then we'll be learning about the transconductance, GM. Then the concept of fast transistor has been introduced. Later on, NMOS inverter pull-up to pull-down ratios would be discussed for an inverter driven by another inverter, and then inverter driven through a series of fast transistors. Then all the different forms of alternate forms of pull-up circuits would be discussed. Then the CMOS inverter by CMOS inverters will be studied, and then last for the first unit would be latch-up in CMOS circuits. This is the total first unit concept. Then second unit concept is depending on how the MOS diagrams will be represented. That is in the times of stick diagrams, and then layouts, how the layouts have been there. We will be learning the design layouts, rules of that one, using of lambda based design rules would be studied, and how the contact cuts have been defined, how the layout diagrams will be there using of lambda based design rules. That would be studied in the first part of your second unit. And in the second part of your second unit, you will be learning about the circuit concepts like sheet resistance. What is the sheet resistance? RS. Then capacitance of layer, area capacitance of layer, and then delay unit would be tau would be studied over there. Then to that one, the final you will be learning about the rise time and fall time estimations. This is about your second unit, which will be completed in 9 plus 3 tutorials. And the third unit consists of scaling of MOS transistors, MOS circuits. So the first part would be on how the MOS circuits can be scaled down to a minimum sizes, and what are its limitations of scaling, and what are the factors are being affected onto this scaling. Then the second part is an creative part, which is like subsystem design and layouts would be discussed in the third unit second part. It would be like switch logic, gate logic, examples of structure design, clock sequential circuits, and system considerations would be discussed. The fourth unit is based on Verilog HDL. All the concepts of Verilog VHDL would be discussed over here. How the hierarchy modeling concepts will be discussed, and different data types will be discussed over here. And the ports, gate level modeling, data flow modeling, behavior modeling, and all the design examples relating to all the different modeling styles, and the functions would be discussed on this. So this would be the total fourth unit is dedicated to Verilog HDL. So the course for VLSI has been beautifully designed by taking into consideration each and every concept into this consideration. So thank you. You would be having two textbooks preferred over here, Douglas A. and Bucknell, and Kamran Eschergan, Basic VLSI Design. This is of PHI Publication House, and this would be the third version, which covers the first 6 chapters of this textbook are referred over. Another book for Verilog HDL, A Guide to Digital Design and Synthesis. This is a Pearson Education Publication House, 3rd edition. So in the part 1 from chapters 2 to 8 are preferred for learning on the Verilog VHDL as per the syllabus is designed. So beyond to the syllabus, if you want to read The textbook is open to you. You can read the more the chapters, the more knowledge you can get it up over there. These are the course learning outcomes. So the first outcome, once we learn this course, would be you will be able to explain the various steps of fabrication process and electrical properties of mass transistors. The students on the completion of the second unit will be able to describe the color codes, symbols, and sketch the stick diagrams and mass layouts of the mass circuits. On the completion of third unit, the students will be able to determine the scaling factors for various device parameters and outline the structured design approach for several example circuits. On the completion of the fourth unit, the students will be able to write Verilog description of digital circuits using behavior data flow and switch levels of abstraction. So these are the course learning outcomes of the basic VLSI design course. This was the total course over here, introduction to the course of VLSI design. I hope that on the completion of this lecture, the students are able to define the course learning objectives and outcomes of the VLSI design, and you got a somewhat familiarization on the VLSI design course and the textbooks required for this course. Thank you, and more information you can get it from the I2RE website, which is the courseware website, which is designed by Kids Warangal, especially for the students on online working and learning platform. There are the special assignments related to this one. There are certain research papers and patents have been listed out. Please go through that one, and all the materials and handouts, lecture slides will be provided onto the course web. Please go through that one. Thank you everyone.